Okay, hey, Stockholm! Hey! Thank you. So my name is Marcus Biel, and today I want to show you how you can live refactor some legacy code. Okay, so first thing first, what actually is legacy code? Legacy code, from my personal opinion, is actually very valuable code. If it wasn't valuable code, we could just throw it away, right? But we cannot, because legacy code usually has high value to the company that we're working for. It might be running for many years, let's say 10 years in production. And they even want more features from us. They want us to maintain that code, because it is valuable code, right? The problem is on us developers, because there are some technical problems. The code has some defects, the code has some age, and automated tests might be completely missing, right? There is a vicious circle. We cannot understand the legacy code. To understand the legacy code, we would have to refactor it. But how can we refactor it if we don't understand it? We would need a very tight net of unit and integration tests, right? But to write these unit and integration tests, we would first of all have to understand it. And that's the vicious circle. So somehow we have to solve that. Now think about this for a moment for yourself. How can we solve this vicious circle? Okay, so let me tell you how I would want to solve this vicious circle. Have you heard about Jenga? That's good. For those of you who don't know it, it's a game played by two players. There's a tower like this, made of wooden sticks, right? And then you play this in turns. First player takes out a wooden stick, second player takes out a wooden stick, really carefully, because we do not want to make the tower collapse. Because if the tower collapses, the player that touched the tower the last is the guilty one, is the one that lost the game. And that's what we do in the business, right? Well, we don't have wooden sticks, but we have code. And we don't try to remove code, we try to add code on top, right? So we have this big stack, and we carefully try to add more and more code without breaking it. So we are really careful, and we add the minimum amount of code changes needed. We will not refactor it, no. Right? And then, all of a sudden, the code will break on production. Boom! Yes. And when this happens, what do? Finger point! Hang them higher! Hang them higher! Hang them higher! Yeah, that's what we do, right? Okay, sorry for being a bit sarcastic. I know we have some really cool people in this room. Smart people. You have responsibility. You want to live up to that responsibility. So obviously we do want to break this vicious circle. So what can we do? Seriously. Well, the thing is, we have no automated tests, so we just have to face that. And the thing is, we may break the code. And actually, I can guarantee you, we will break the code. Well, for this refactoring, I broke the code many times, right? So we have to take this as a given fact. So what can we do? Well, first of all, I would say things are not as bad as they may seem. Because usually, I mean, the company that we're working in, they're doing business, right? They want to earn money, so they're not stupid. They know about all these risks, so they somehow want to counter these risks. And what usually is in these companies is, if there are no automated tests, then at the very least, there is a large amount of QA people, and they can do manual testing. That's not the perfect scenario without any automated tests, but it's still much better than anything, right? So, these days, most of you are probably running in the cloud. If you're running in the cloud, for example, the Oracle Cloud, you could have a tool, for example, Istio, and with Istio, I don't know if you have heard of Istio before in this conference or somewhere else, we can run a canary release, right? And the canary release is quite a cool thing. So if you don't know about it, please look this up. we can have our main release running in production. And now, once we think we're ready, and once the QA department gives us the thumbs up, saying they also think it's ready because they have tested this in a dev environment, we can release this in production in parallel to our existing release. But with Istio, we can just route a minimum amount of users to this new release. For example, only the QA department. Now they can continue their testing in a real environment, in a real production environment, right? And again, when they say thumbs up, looks really good, we can switch over. And obviously, as I said, things can go wrong, and they will go wrong, so there might still be bugs hiding, and there might be a big breaking change. The cool thing is now with a tool like Istio, with just another click, if we have to, we can just as well switch over back to the old release, right? And this takes out a lot of risk from us, right? So, but still, we have to be really, really careful. But now let me show you actually my code, right? So this is the code that we want to refactor today. It is a brute force Sudoku solver. When I was preparing this talk, oh, that. Okay, yeah, I have no battery, and yeah. Okay, I hope it stays. I just probably have to keep moving my mouse. Okay, so this is a brute force Sudoku solver. When I was preparing this refactoring talk, I was hoping to show you some really complex business logic. And I was looking for code that I could show, because obviously code always has copyright. I was asking on Twitter and also LinkedIn. Ashley Free sent me here this code. When I saw this, it hardly has 300 lines of code. I thought, hey, this is way too simple, right? 300 lines. I don't know much about Sudoku, who cares? I'm a smart guy, so I can do this in an hour and it will just be boring. Well, anyway, because I didn't have a better alternative, I started working on this code. It took me a few hours, and I had to understand, oh, maybe I'm not so smart, right? Because that's what we all do, and that's something that I want you. We have to keep this in our minds. We are smart, yes, but maybe not so smart, right? Things are often much harder than they seem, and we have to have a very deep understanding of the business that we're working in. So I don't know about you. As I said, when I started, I didn't know about Sudoku, or at least not in detail. For the purpose of this talk, we will now assume we are all the experts of Sudoku. We know Sudoku inside out, right? If you don't, it's not a problem, because it's not a talk about Sudoku, obviously, but we will assume, because that's the first condition. If you don't know the business that you're working in, you should work on that first, right? Okay, so this is a code written in 2005 in Java 5 by Patrick Chan. Patrick Chan is actually also not a bad developer, right? At the moment, I think he's like the main architect at Yahoo. He has written that 15 years ago. So obviously he has learned a lot in the meantime also, but also he has written that in Java 5. Today we have much more power at our hands, obviously. And also, he had a different goal when he wrote this code. His goal was not to write productive code. His goal was not to write code that would be running in production. He had a little website where he was showing some few Java examples. And his goal was just, to show what can be done with a few lines. So his goal was to write this brute force Sudoku solver in the minimum amount of lines needed. And he wanted this to be very, very performant code. So he used some tweaks, quite smart tweaks actually. But these tweaks, obviously, are really hard to digest when we want to refactor this code and we want to make this clean and maintainable and so on, which makes this interesting. So this is very condensed code. Okay, so I said we have to be careful. In an earlier talk, I said we have to proceed in baby steps. And obviously, I said baby steps quite often. So I got this feedback, hey, okay, I think I got it, baby steps, baby steps. Well, I have to tell you, no, we have not gotten it, I have not gotten it. Just on the weekend, again, I was coding, I was going too fast. We continuously go too fast. So we have to, every day, every hour, we have to say this as a mantra, we have to proceed in baby steps, right? Especially so, generally speaking, but especially so in this case, that we have a code that has no automated tests whatsoever. This is dangerous ground, right? This is not for the English, not for the simple people. So it is running code. Let me prove this. As I said, if it wasn't running code, it wasn't valuable. So here we start with this field here, 9 rows, 9 columns, and 9 boxes. Some fields are pre-filled, others we have to fill. And then the algorithm fills in here the solution, right? Here it found 2 solutions. Okay, so I'm not going into much more details. This is read from this grid.txt file, so there's also some file I/O going on, which makes this a bit interesting. But the output is on the console, so there are some complexities in the code. Now we have no automated tests, and we have to proceed in baby steps. What is a baby step? Well, from my definition, a baby step means we, first of all, are very, very careful, and we always start with the low-hanging fruits. Whatever is a low-hanging fruit for you, right? What is simple for you might not be simple for me, and vice versa, right? So this is a bit of a personal approach. Obviously, there are, I think, some common things that we generally think that are easy, which I will show you. But still, if something is too big or too small for you, adapt the process, right? So we start with the simple things. And we should avoid to break the code whenever ever possible. So we should especially use our IDE whenever possible. The IDE is a tool, it can help us tremendously. Okay, so starting with the simple things, let me make this smaller. I think the most simple thing that we could think of is just formatting the code. This is obviously not the original code. As well, Ashley, as me, we have slightly adapted the code to make this even more legacy style. Here you can see the white spaces and the tabs. I made them visible, but actually this is also how I code because I want to see that visible. And that's my experience very often from legacy code, that we have a mix of tabs and spaces. So when I see code like that, it already smells of legacy code, right? And I don't care if you prefer tabs or spaces. Well, I do care, but they told me I should say that. So, okay, jokes aside, I don't care as long as you are consistent, right? I met some developers, very smart developers, that put a lot of ego in their code. I think as developers we should work in a team and we should try to avoid to put our ego in the code. And our personal code style is ego in the code, right? So we should agree on some kind of common code style, whatever that is common in your team, that's fine. And that includes obviously the formatting. So here, right, I would want to start auto-formatting the code. You could also do this with a commit hook or whatever. Here I'm just doing this simple anyway because I just have 2 classes at the beginning. Okay, and now the code is auto-formatted. And if we want to get sure, we can obviously run the code again to make sure it's still running. Okay, so I have not broken the code, great. So, what can we do next? Write tests. Yeah, that's a good comment, because yes, writing tests is like the most important thing in refactoring. But time is short. Let me see, I've used 15 minutes so far. So, well, I can't show you everything in just like the remaining 35 minutes. I already wasted 15 minutes, blah, 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 right? So I had to make some compromises in this talk. Well, the talk will be divided into several phases. And whenever I'm at the end of a phase, I will jump over like in a cooking show, ta-da, the cake is ready, to show you the end result of the step, right? And the end result of the first phase should be the first running test. And when the more dirty this code is, the more legacy style this code is, the harder we understand this code. Obviously, the worse this test will be. But I'm happy with any kind of automated test, right? Some automated test is better than no automated test. So in this case, at the end of phase 1, we will have just a very, very simple smoke test, right? And the test can show us that we have not made the code worse than it was before. There are some bugs hiding in the code, but I mean, this is just a refactoring, so we don't necessarily have to improve this. Actually, we should not introduce new functionality as much as possible. But if we can at least ensure that we don't break it, that's a good first start, right? But in this refactoring in this talk, I will not be able to do what I would normally do, and that is I would really follow the test pyramid with lots of unit tests, also component, unit tests, end-to-end tests, and so on, right? Yeah, but we will assume that I would normally do that, okay? So, now, let's go to the code. Let's see, let's make this smaller. What do we have here? Let's have a quick look. I think we have some time. Okay, so you see there's lots of documentation. That's also, I think, a good sign of legacy code. There's a lot of information, but it's problematic because even the documentation might be lying, and actually it is lying in this case here. This I found out is actually wrong, right? So documentation is good. It always depends. If you document the why, if you document whatever you cannot document in code. But everything that you can document in code, you should document in code, right? So, for example, this one here, it says array that contains values of all 81 cells in the grid. And here we have this magic number saying 81. And it says cells. So I guess that's just that, right? So why not getting rid of that and putting this knowledge into the code? So let's call this max cell amount. Okay. And now let's directly extract that. Sudoku constants. This is small. My eyes are bad. Sudoku constants. Okay, yes, create it. And now on top, I can, oh, sorry. Yeah, this is not what you should do. New int. Okay, and now an import. Yeah. Okay, so that's what we can do. So why did I create this constant class here? This, from my perspective, the way I did it now, can be a pattern, can be helpful. If you overuse that, it can be a really dirty anti-pattern also, which is true for, I guess, all the patterns, right? I do this at the beginning so that it helps me to get this understanding. The first phase, the main goal is A, to get an understanding of the code for you personally, and the first goal is still to write this first test, right? And whatever helps us in this way is good. But this class will grow over time. The more it grows, the more dirty it will be. So within this refactoring, I would then want to start to extract constants to their own classes, to enums or whatever. I would constantly refactor that, so this is always iteratively going on, right? Okay. So I would go on, for example, here 9. Well, I'm obviously proceeding here a bit fast, so I mean, this first phase, by the way, if I would do this now, the entire thing could already take me 2 hours. The entire refactoring, and I exactly know what I have to do, will easily take me 8 hours, right? So I assume we have spent some time reading the documentation, reading the code, trying to understand the code, and when we did, we will finally come to the understanding what this is here, in this case, is the unit length. Okay, so. And we can directly extract this to my constant class again. And we can make this a static import again. Okay, and we continue like this. I did specifically not do this for all the 9s, because not every 9 is necessarily the unit length, right? And we have to check this, because this is our documentation from then on. Okay, so in the first phase, we do these simple things. We extract magic numbers, we rename variable names, for example, this one here, RD. Now, I told you this is a personal thing. For me, I never ever like these 1 or 2 digits characters, variables like RD. So I really much more prefer to call this reader. So let me do so. But you might say, well, how is reader better than RD? Well, obviously, right? But it helps me to touch the code. That's how our brains work, right? If we're just reading the code, it's all forgotten. By doing this trick of doing simple changes that don't really hurt, my brain starts to get an understanding, and my brain starts to realize, hey, I will not get out of this. I have to really dig deep, and I have to understand this. Okay, and over time, the more knowledge we will get, we will go back and we will give the reader a better name if we can. Okay, then let's see. There is, for example, log. This is an interesting one. It took me a while to understand what he actually meant with log. I thought maybe lines of code or something. Well, I read that, I really digested it, and I came to the understanding what he actually means here in this case is cell index. So let's name it so, cell index, right? And then we see here again a comment saying compute rows and columns. So seems like this is the row. Well, actually it's not. What he means here is the row index. And I might be picky, yes, I am, because I think we have to be picky in this case. We have to be very, very precise with just the variable names. Excuse me. And then, once we did all of these small things, we can start to do a few bigger things, like for example, we could extract this as a helper method. And we could give this the name row index, right? If you prefer get row index, that's also fine with me. I'm just not a big friend of getter methods, but that's a different topic. Here, by the way, he says it again, compute row and column, right? So we even found now the first duplicate line of code. So once I'm done with this phase, now it's questionable, is this code really better or worse? It depends, right? But this is not the goal here. The goal is really like to get this understanding and to see like how does this code work, to familiarize ourselves with the code, to find duplicate code so that we later can clean this up properly. Okay, what we should also do, by the way, I wanted to tell you initially, our IDEs these days are super powerful, right? I'm here using IntelliJ IDEA because I really like this, but if you use any other tool like Eclipse or NetBeans, they all can help us to refactor our code. So we should make use of this, right? I can click here, and then again, I would spend a lot of time reading this, blah, 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 blah. Okay, this is an interesting one, by the way, because here clone is used. So here it tells me I should call the super method. Well, I will not do that because I instead would want to remove the cloning, right? Because that's also not so nice. So I read that, and when I agree, for example, yeah, let's replace this with string builder, then I do. And with just one click, this is done. Assuming that our IDE is not buggy, I'm pretty sure this is going to work, at least better than when I manually type this and, yeah, introduce some kind of typo or whatever, right? Because we really, really do not want to break the code, right? So let's ensure this. Is it still running? Yes, it is. Okay. So now let's jump to the next branch. Ta-da! The cake is ready. And let's see what we could achieve in this very first phase. So now, I have removed where possible some of the documentation. Some is still there where I'm still not so sure, where I still need some more understanding. But some has gone. I have also sorted here the variables, the methods, and so on. Because, for example, here I speak of rows, columns, and boxes. Before it was mixed, it was columns and rows. I don't know about you, for me this was like, oh, let's sort this and let's stay consistent to make this code really clean. Okay, so now I have lots of these constants here. Find empty cell, no empty cell is found. Is it empty? Then I have this update function here. The reset function. I have these helper methods here. By the way, this is not properly sorted, so I was lying to you. Yeah, so here's a create method. That's interesting. You know, I would want to put this in a factory, and we will later do. So we are obviously not there yet, right? So what else do we have? More helper methods, and you know, this is also a smell. It is more readable, I think, but it's not clean. So we are slowly getting there. The clone method is still there. A large to string method is there. Ooh, yeah. Let's see, what else do we have? This was the grid, the solver. So here we have the file reader, we have a grid. This I changed to a collection because actually collection was good enough for me here. So these kind of small changes I did. Okay, so let's see, is the code still working? We continuously have to check that. Yes, it is. And ta-da, I was able to write my first test. Let's also look at the test. Okay, so the test is very, very simple. What it does is, it just reads in my grid, you know, that thing here. And then I just copy and pasted what I got initially from the console, and I took this saying, well, this is the first solution, this is the second solution. Now, by just doing this very simple, stupid test, obviously I have a very, in this specific case, I have a very tough test because it tests the entire algorithm, because every number has to be there, including the formatting, everything is tested. So you could say, perfect, you have tested everything, you're done. But tests should do more than that, right? Tests should also help us to find exactly which line is broken. And this code will hardly ever do, right? Besides, tests can also give us feedback, is the code clean, and so on. Okay, so, but still, we have a first test, and that's better than not having a test. Now let's go back to the code. So, if we look at this, there's this weird thing here, right? Whew. When I saw this, I was like, lost. So I don't know about you, and it keeps repeating. There's the same kind of thing, more of that, more of that. Is that it? I think it's like 3 or 4 times in the code. So A, I see now there's lots of duplicated code, and B, I would want to change that, but how can I change it if I don't understand this? Now, well, I do understand something of that code, and I hope you do too. So I do know this is about shifting. I do know this is related to some binary bit fiddling logic. As I told you, this is highly performant code, right? So with this bit fiddling, he was able to achieve really nice performance. The question is, do we need that kind of performance or not? And I would here say, well, you know, my computer is so fast, this is very simple, it is fast enough. So I would be willing to refactor that, to make this more readable and more maintainable. But how can I refactor it if I don't understand this, right? So, well, this is a shift, I know. But is this a left shift or a right shift? And is this shifting 1 by value, or is this shifting value by 1? Maybe you know, maybe you don't. If you don't know, Stack Overflow, right? But do you want to trust your main production release on Stack Overflow? Maybe not, right? But maybe you have a good friend, a former teacher, maybe you know the perfect book, which you can trust. Okay, cool. But even if you do know about shifting, what about the combination here? There is this binary AND. Okay, so hopefully you also know about how this binary AND works, you know, 0 and 1, that stuff. But what about the combination now? Now I think it gets tricky. Even if you do understand the both parts, the combination of that and the fact that this keeps repeating in different variations, here with an OR and here with God knows what that is, right? Gets tricky. And now I'm lost. I can go home, I can go crying. There's no way of how I can proceed. No, actually, there's one thing that we should never forget. We are developers. We can run little code experiments. And I mean, coding is fun, right? So why can refactoring not be fun? So I prepared this here a bit. I have just copy and pasted these 2 lines, update and reset, for an example. There's more in the code, but you know, just as a quick example of how I would solve this. So here is that OR that we saw before, and here's that something, right? So let's see, let's play with the code to understand how it's working. Okay, so I start with this empty 0. I have a value of 3. I told you we need some understanding. So I know it's related to the base of 2. So when I print out the result, I have to print this out on the base of 2 to see something. Okay. So now I want to call the update function, and the question is, what will be the result? Think about this for a moment, and then let's try it out. Okay, so I call this. Obviously, it's not a test. I'm just abusing tests here because it's a very easy, quick way of how I can demonstrate this here. So I get 1, 0, 0, 0, 3 zeros. Maybe this should tell me something, but I'm unsure. You know, I'll never trust that. Let's try this again with a 2. and I get 1, 0, 0, 2 zeros. I start to understand more of this, how this is working, right? All good things are 3, so let's do this again. So now if I'm right, I should expect 4 zeros, right? And there they are, I got 4 zeros. So now I think I understood how this is working. The 1 is a flag that indicates just if in the row, in the column, or in the box, there is the given number existing. And that is very smart and that is very performant because he does not store the exact number there. He just stores the information, is there this number existing? Okay. But now I would also want to know what happens if I do this twice. Well, if I had a wish, I would wish this would throw an exception, right? Because this is the kind of hiding bugs in our code, silently hiding there, everything fine for months, and then suddenly, bam. And no one has an idea why the code suddenly breaks. So we really want code that is failing fast. So let's see if this code is failing fast when I do this twice. Or do we get a 4? Do we get a -4? Do we get a 16 or whatever? I don't know. Let's just run this. And we get, again, a 4. So there was no warning whatsoever. Why is that? Let's look into the code. Well, here we have an OR. So do you remember how does an OR work? 1 or 0 is 1, and 1 or 1 is also 1. So that's why it stays on the 1. And that's something that I really don't like, because this is dangerous, right? So now I have the best motivation, I have the best arguments to go to my boss and say, hey, see, we have a problem, I can prove that. We have to refactor the code, right? Okay, so now that I understood this, let's also look at reset. So how does that work? Now I think it's much easier because we already understood how update works, and reset works similar. So with that knowledge, I would assume that if I start with an empty 0 and I put in a 2, right? No, sorry, I'm confused. So I start with a 2 because I cannot reset something that is not existing, right? And then I want to reset that, so I would expect that again I get an empty 0. Let's see if my expectation is met. And yes, it is, so we get a 0. Cool, so it's working. But now, what does happen if I run this reset before having a 2 in there? Again, the same question, what will happen? 2, -2, warning, exception. I would hope for an exception. And my expectation is not met, we have a 2. So now again, I understand how this is working, but again, we have a big problem. A bug might not be found, so we should fix that. And if we look at this here, we might come to the final understanding, this is actually an XOR. And that's how an XOR works, right? If there was a 1, the XOR will turn it to a 0. If there was a 0, the XOR will turn it to a 1. And that's why, if we start with a 0, it will just work as if it was an update. Now, I really don't like this code anymore. I really want to change this. It might be highly performant, but if I don't need this performance, I think we can get rid of this. Okay, so now I have to do my homework. Now I have to do some research, like how else can I do that? So I did that, right? And I found out, well, actually, this is just primitive int arrays. This is also not very object-oriented. And I found out there is a class called bitset that does exactly the same thing. So why not using that instead? Bitset, okay. And let's check the code. So this was written in Java 1. So this is really a very old class. But as we'll see, this is much more helpful because obviously there will also be done some checks, so I can use this instead. But again, ta-da, the cake is ready. Let's jump to version 3. And there I have already done that. And a bit more. Let's see what happened. Okay, so first of all, I have here the isAllowed function. Now isAllowed calls get on my bitset. Get. And if we look into this, we see, hey, there's actually an index out of bounds exception because this checks the index, invariants are checked, really cool, really good. So we can trust on that by just using this library. Okay, so what else? Here, update is set. It's not perfect yet, right? I would wish that update would call update to make this code even more speaking, but I think it's way more speaking than it initially was, right? Reset here calls clear. I think that's really close. Reset and clear now really starts to be speaking. And again, I see so much duplicated code, right? The more we clean up, the more we will see. Layer after layer, we will clean up slowly, step by step, in baby steps, and the more we see. Oh, by the way, I think I did not say. So if after the 5 to 25 minutes, your code does not compile, throw it away, start from scratch, right? So really, because otherwise you will be lost. This is important for baby steps. Okay, in the worst case, you have lost 25 minutes, but you will have saved debugging sessions of hours or days. Okay, so let's see, I did some more changes here in this version. What all did we change? Besides all these helper functions, I have now introduced here the static method parse. So for me, this is the next logical step. Now, after working a few hours with this code, I understood enough that, for example, there is file parsing going on. I also understood this because here, if you just look now in my constant class, which has grown a lot, I see things like new line car, empty dot car, empty zero car. So there is a lot of this in here, which already gives me a smell. There is file I/O going on. And well, I would want to have really cohesive code, high cohesion and low coupling. To achieve this in the first step, it's a good way of just extracting this kind of logic that belongs together into their own units. And this is, again, not perfect. I would try whenever possible to avoid static, but it's a good step to get there, right, eventually. Because this helps me as a human to understand better things when they are together. Same for printer here. I have two different printing methods in here, and this is not really clean yet. But still, it is much better because it's together, and this class only now is related to printing. Also, I have extracted here this factory, which is not only responsible for creating the grid, but still, like, I don't really like this code. There is a lot of business logic here involved, so we still have to separate this, but slowly, slowly, we're getting there, right? Okay, so what else do we have? We have a small runner class just for running the code, and we have a small solver class for solving the code. Now, this is really, really getting small. And I would want to like even introduce later an interface, so we could even implement other solvers, but step by step, getting there in baby steps. Okay, so now let's look again at the code, and let's see what we have. Well, we have a grid of cells. Here again in the constructor are cells. We have find empty cell. Is the cell empty? Cell index, over and over again. Row index, box index, column index, cells. When I see this code in this state, this is when I say a new class is born. Because I really see we have to like create a new class to make this object-oriented, to extract this concept. And I have already prepared this because now just 10 minutes left and I have to speed up so we have maybe some time for questions. But anyway, so I extracted this. This is a final class. I would try to make as many classes as possible immutable, and I would want to make cell as well as grid later on also immutable. But in the first step, I was not able to. But at least this cell class here is using the position class. The position class is an immutable thread safe class, which can help us a lot because it makes a lot of the preconditions way easier, because whenever this is created, this will never change later on. Now I'm statically calculating all the indexes. This is actually a performance optimization. We could also do this on the fly. Well, it doesn't really matter to me if you do it one way or the other, right? But the code at the moment is not compiling, as you may have seen. And it's not compiling for a reason, because, yeah, now we have to do this. And now really starts the most dangerous part of our refactoring, because now is the first time our code is not compiling. So please, danger zone. Because of that, we should be as quick as possible to make this code compile again. And we should do this and only this, baby steps. Along the way, there will be many things that we might want to have the feeling, oh, I can quickly do this also. No, don't do this also. Make this code compile and only make this code compile. period. Okay, so let's start. Hopefully I find the time to finish this up. So, find empty cell, cell index. Let me make this a cell. And this is the kind of place, right? I mean, we're filtering here through the cells. Why not using a stream? Would be so much nicer. No, at this step, I personally, maybe you want to proceed faster, but I personally would say, let's do this later. For now, let's just focus on making this code compile. So, cell is empty. Return the cell. Okay, and here return null. Returning null, ooh, is evil. But again, we're not focusing on that now, we will do this later, right? We will only focus on making the code compile. And now, cool thing, I can remove this helper method again, right? As I said, it was just there to help us to get there eventually. And then cell. And this is a cool part of this refactoring, because now I really feel this power of object orientation, because I don't have to code this anymore. I can just ask my cell, hey, cell, give me please the row index, right? And this makes my code so much more readable. Cell, give me please the column index. Okay. And I can actually copy that, because this is done several times. And the more you touch this code, you will see the more how much code duplication is in there. So here, cell dot update with a new value. I could also give this the name new value, but for now I will not. Okay, so what else here? Cell dot box index. And let me check the time. Maybe I switch over so that we have time A for questions and B so that we can see the next step. Yeah, I guess you get the idea. I just make this compile. And once this compiles, I will have this. Now because I also want to spend some time looking at this solution here. So this is the last code that we see for today. And this is far from perfect. This is far from being complete. But the cool thing about it is, I think now the code is in a state where we really understood this, we are able to understand this. After hours of working on this code, we can now focus on the real complex stuff. We can now make this really clean. We can now think about the bigger concepts like architecture and so on. Now we are not anymore in this refactoring state. Now we are in a state where we can think of how can I change the logic to make this actually even better, right? Now I have a method, for example, here has empty cell, which is find empty cell and is it present. So I'm kind of abusing here an optional, and I know people would tell me you shouldn't do that. I personally like this in the specific case because it makes my code readable. Even IntelliJ IDEA doesn't like what I do here because it tells me, hey, you're using this get without is present. I personally think simplicity is key, and the code here with just one line is so simple, and I know that the other class is just calling this when it's safe, so that I'm doing this. But you know, every case is different, so if things are complex or more complex for you, you can also add an assert if you like. Okay. So here now we are using streams, we're filtering this, so this really is a set of a lot of 1, 2, or 3 liners of code. And it gets much more complex. However, we have not gotten rid of this duplication there. And I have another branch where I have gotten rid of that, but because time is short, I will not show you, just trust me. The way I extracted that, it got more complex. The code duplication was removed, but the code was way harder to digest because I extracted this into its own state object. And when I saw this, I was like, no, I don't like this. I would rather prefer this code duplication to be in the code than to have this code so complex that no one can understand this. So this is always a balance that we have to do, right? There are other ways, like at this level, I can think of other ways of improving this code. For example, here, these bit sets. These are still there because they initially were there. I improved it a bit, but actually not so much did I improve it yet. Because the thing is, this is the performance thing, right? And again, I would ask, do we still need this kind of performance? Can we just get rid of that? And can we just have cells yeah, and this would be a way of how we could maybe improve this code, but I mean, it depends if we have the time or not, but now really the code starts to get understandable, right? Okay, the factory still is very unclean. This is now really my biggest pain point, and we would really have to extract way more. There's still a mix of parsing and business logic, but yeah, we're getting there. So I hope you were able now to understand the idea of how you proceed in a refactoring. To repeat, be brave. Proceed in baby steps, however, because we are not stupid, right? Write this first unit test, not unit test actually, because first of all, it will be just an integration test, but write this automated test as fast as ever possible and continue to proceed. Go on layer after layer after layer. It's like an onion, right? You start really unclean and you eventually get there and make it cleaner. It's a really slow process, but it's worth it. And at the end, it will be good. Okay, so thanks for your time. Thanks for having me. Now we still have a few, like 3 minutes left, so you can ask questions if you like. Okay, you?
Yeah, would you deliver all these cakes in between? One cake would be deliverable that you actually put in production.
I would say it depends. I mean, it's difficult to answer. If there is value, and if it's like stable, better than before, we could deliver it. The question is like, why should we deliver it? Do we just want to deliver it to take out stress so that we get a better feeling this is okay? Could be an argument to say, yeah, we want to deliver this, and if it's not going well, we can still switch back, as I said. So this depends on, you have to talk to the people, you have to talk to your team, you can, but you don't necessarily have to because you don't have new features. Depends. Okay, anyone else?
How many lines did you end up with?
Sorry? Yeah, good question. I don't know exactly, but I know exactly that it was more than before. I mean, our goal is not to write, this was his goal, right? His goal was to write this in a minimum amount of lines of code. Then obviously, like, this will be a bit more, but I think to make this more readable, it's really worth it to spend these extra lines. And as I also said, I'm not there yet. Actually, I'm still working on this, and I still have some fun. I'm planning a next talk to bring this on even another level. The more I work on this still, so I'm not there yet. It gets, again, smaller. At the moment, it's like in an intermediate state, where it's maybe 30% more than before, but I think more readable. But now I can, as I said, digest this and it will shrink again. And the end result, I cannot tell you, and I don't care too much. If it's like 30% more, that's okay. But usually, like this is the case here, because it was very dense code. But generally speaking, my experience is that when I refactor a code like this, I easily end up with 50% less code. Okay? Thanks. Anyone else?
I see the runner test class. You improved on that?
Sorry?
The test class is no runner test.
Yep. That's still in the same state as I told you, and it's not a good test. And so what I would want to do to make better tests is actually, I would want to introduce a lot of dependency injection, which is why in the next step, I also used, for example, in my case, Micronaut, which I love, so that we're able to use dependency injection, and then we're able to better test each unit specifically. Here, this is not a good test yet, as I said. Yeah. Anyone else? Okay. How much slower is my code? I don't know, like percentage-wise, but I do know it was slower. Yes. But as I said, like my goal would always be first make it run, and make it as clean and maintainable as possible. If you too much work on the performance optimization at the very beginning, you end up with spaghetti code like this, and this is dangerous. And you might, like, I was working for a client, for example, they had an assumption where they said, oh, we should take all the requests, and we should, to the front end, we should send the minimum amount of requests. We should optimize that. And then they optimized that for this case. Then we ended up with JSON files that were over 1 million lines of code that were sent because we wanted to send as few requests to the client as possible, and that was a bit big, like 20 megabytes for each request. That was a premature optimization, so with that we should be careful. However, if you start to write this simple and clean, then you measure your performance and you see it's okay, it's fast enough, then we're done. However, if you measure no, it's like 30% not fast enough, then we will see where exactly is the performance spent, where exactly do we have to jump in, where exactly we do a tweak on these conditions. Because like just thinking you know what's going on, you will always be wrong. Well, I will always be wrong. Maybe you're smarter, but I would really tell you you should first of all write the clean code, first of all make this maintainable, and later make analysis, and not just from your stomach feeling. You know, I have a big stomach, so I have lots of feelings, but you might be wrong. And testing this, performance has to be tested.
More question. What about the manager? They say, okay, now the code is 10% slower, they say. I don't want that. So what do you say then? How much value have you put into the new code?
Well, then I would ask, why do you not want that?
10% slower code.
Yeah, so why do you not want that?
That's obviously a question from the manager. They want everything to be fast.
Yeah, but managers normally, like either they're technical managers, so they would understand, or they're not technical managers, so they wouldn't care, I would say. But still, you know, nothing is ever black and white. Yes, there are some interesting managers, so let's just, you know, I want to keep this question as it is. There are some, I also had some interesting managers, let's say it like this. I had managers telling me, we have to fully optimize this, we have to make this concurrent, and I said, why? And they said, because, right? Because we can, and so I did, right? I mean, still, you know, we have to make a living, and so if you like are forced to do such things, then sometimes you do. Yeah, it's life. It's not like, you know, it's not dream world. Anyone else? Any more questions? Okay, so thank you. If you like, there are stickers that you can grab. And if you need someone to refactor your code, by the way, give me a call, send me an email. I might remotely be able to help you. Thank you.